page page 59, right? This one. Okay. So Charizal, you already got the document I sent, right? So that one have a structure question paper 2. I sent in the group, 5K group. Okay. So we continue, right? Right. For this one, okay. So it says here the diagram 7, okay, shows the situation.
Teacher, you're not sharing screen.
Oh, sorry. Okay, wait. Share. Share. Right. Okay. So page 59, I think. Okay. So number 7. So it says here the diagram 7 shows the situation of two trolley before and after the collision, right? So asking you the what is the velocity of both trolleys after collision. So this one you have to know whether it's elastic or inelastic. So you can see here it say it stick together. So mean if stick together, this one is inelastic. Okay. So the formula should be okay.
Teacher, isn't this question we done already?
I don't know. You said at page 59, I forgot. But for 5M, I think I already discussed with them in the school. But 5K, I don't think so.
It's page 59, teacher.
59. Okay. Not this one. This one is page 59, right? Or maybe yours is different. This one already discussed.
Already.
Alright, paper 2.
That one already?
Okay. So,
No, this one.
okay. So start from this one. Okay. Wait, I erase first. Okay, so this is diagram 3.1 shows a cheetah chasing a deer in the wild world. So given that the mass of the and velocity of the cheetah and the deer is 60 kg, 20 ms negative 1 and 70 kg. So 60 ms negative 1 respectively. So this one diagram 3.2 shows the cheetah successfully landed in jaws on the deer and both of them are moving with same velocity of v and s negative 1. So name a physical quantity that relates the mass and velocity. So this one is momentum. Because momentum is mass multiplied by velocity. Okay, and then state the type of energy that is possessed by the running cheetah. So running cheetah means it's moving. So any object that moving that have the kinetic energy. So this one is kinetic energy. Alright, and then calculate the final velocity of cheetah and the deer. So since after the cheetah, alright, okay, the cheetah bite the deer here. So this one they move together, right? So this one is inelastic collision. So the formula is M1 U1 plus M2 U2 is equals to M1 plus M2, okay, multiplied by V. Okay, so the mass of the cheetah is 60 kg. So 60, okay, and then the initial velocity for the cheetah is 20, okay, plus with the mass of the deer is 70, okay, and then the initial velocity of the deer is 15. Okay, and then this one will plus the both of the mass. So 60 plus 70. Okay, so multiply by V. So if you calculate, you got the V is 17.31 ms negative 1. Okay, so this is the formula for inelastic collision. This one you have to remember because in exam they will not give you this formula. Okay, for D1, it says name the physics principle. Okay, name the physics principle that is involved in the above hunting. So this one is principle of conservation of momentum. Okay, so define the physics principle that you mentioned in D1. So actually this one is the total momentum, okay, before and after the collision is same. So that one is a principle of conservation of momentum, right? So we go to the next question. So this is the essay question number 9. Okay. So it say here diagram 9.1 show a van of mass 1500 kg traveling 25 ms negative 1 before it collides with stationary car of mass 1000 kg. So diagram 9.2 shows the van and the car after the collision. So this one it gives you already the value of the momentum of the van and also the car before the collision, and this one is the momentum of van and the car after the collision. Okay, and also they give you the kinetic energy, okay, before the collision and after the collision. So the first one, the question asks you the meaning of momentum. So mass multiplied by velocity. Okay, so diagram 9.1 and diagram 9.2 asking what happened to the speed of the van after the collision. So you can see the speed of the van, okay, so it will become decrease. Okay, why? Because you know the kinetic energy is half mv square. So let's say if the kinetic energy, the speed is decreased, the kinetic energy also decrease. So in the questions, okay, in the questions given, you already see the van, okay, the kinetic energy for the van before and after collision, it decrease, right? So mean if the kinetic energy decrease, okay, if the kinetic energy decrease, the velocity means also it become decrease. Okay, so the answer should be decrease. Okay, and then the next one, okay, it said based on the diagram 9.1 and diagram 9.2, what happened, the question number 2. Compare the total momentum before and after the collision. So momentum you just 37,500 plus 0. So you still get 37,500. Okay. And then when you add the total momentum after the collision, so 18,000 plus 90,500, so you still got 37,500. Okay, 57,500. So means the total momentum before and after the collision is same. Okay, so the total momentum and before and after the collision is same. Okay, the name the physics principle involved. So this one is a principle conservation of momentum. Okay, and then compare the total kinetic energy before and after the collision. So before the collision is 468,750. So this one, if you plus, if you add both kinetic energy, so even you can see here it only 370,000 something, right? Okay, 370,000 something, right? So means that what this one it become decrease. Okay, so the kinetic energy, so ask you to compare the total kinetic energy. So the total kinetic energy before the collision is bigger than after the collision. Okay, you just add up, okay, before, okay, and then you add up the after collision. So name the type of collision between the van and the car. Okay, so between the van and the car, since the total kinetic energy is not conserved, right? So since the total kinetic energy is not conserved, means it's not same before and after the collision. So this one is actually inelastic collision. Because if elastic collision, you know that the total kinetic energy before and after the collision should be same. Okay, so that one the answer is inelastic collision. Okay, number 2. So what does it mean by momentum? So this one is mass multiplied by velocity. Okay. Okay, and then the next question, okay, asks you to calculate the momentum of the softball if the mass of the ball is 80 gram and its velocity is 100 ms negative 1. Okay, so you know the formula for momentum is mass multiplied with velocity, or you can say P is equals to mv. Okay, so the mass must be in kg. Okay, so what you do is you just change this one to kg. So 80 divided by 1000, you get 0.08. Okay, 0.08. Okay, and then the velocity here is, okay, the velocity is 100. Okay, so multiply by 100. So you got the answer 8 kg ms negative 1. Okay, so that's how you calculate the momentum. Okay, if the mass of the velocity, sorry, if the mass of the ball is increased, but its momentum remains unchanged, how does its velocity change? Okay, so P is equals to mv. So the mass of the ball is increased. So we arrange that P equals to V, P divided V is equal to M. So when M is increased, what will happen to V? V will decrease. So this one is the inversely proportional relationship. Okay. So the answer should be decrease. Okay. Alright, the next one is, okay, number 9. So it say here diagram 9.1 show a stationary pistol on a smooth surface. So 9.2 shows the pistol and bullet after the pistol had been fired by remote control. Okay. So what is the mean by momentum? So again, this one is mass multiplied by velocity. So state the total momentum of the pistol and the bullet in diagram 9.1. So you can see here because it's stationary, right? Means it doesn't move. So the velocity is 0. So means the total momentum of the pistol and bullet in diagram 9.1 is 0. Okay. So using diagram 9.1 and diagram 9.2, compare the total momentum before and after the bullet is fired. So this one you already know the principal conservation of momentum said that before and after the collision, the total momentum should be same. So the answer is the total momentum before and after the bullet is fired is same. Okay. Alright, for 9.2, okay, asking you to compare the magnitude and the direction of the momentum, okay, of the bullet and pistol. So using the diagram 9.2 here, okay, so the direction will be opposite. Okay, so because the bullet moves to the right and then the pistol will recoils to the left. Okay, so the direction of the momentum is opposite direction. Okay, but the magnitude, okay, so the magnitude for the momentum of the bullet, okay, so the magnitude for the momentum, okay, is same. Okay, magnitude of the momentum is same for the bullet and for the pistol. Okay, so name the physics principle that can be applied to the motion of the bullet and the pistol. So this one is principle conservation of momentum, right? So for B, so this one is the explanation question. So 4 marks, okay. So the first one is, okay, I will read you the explanation. So this one is, the first one is the fuel will pump, okay, the fuel will pump into the combustion chamber, okay. The fuel is pumped into the combustion chamber. Okay, the fuel is pumped into the combustion chamber. Okay, I repeat again, the fuel is pumped into the combustion chamber. Okay, so later at the combustion chamber, okay, so the fuel will mix with the oxygen, right? So there will be a fire produced, okay, it will be a burning process there. So the second one is the exhaust gas, okay, the exhaust gas is ejected out, okay, the exhaust gas is ejected out of the rocket nozzle, okay, or out of the rocket nozzle at high speed. Okay, the exhaust gas is ejected out of the rocket nozzle at high speed. I repeat, the exhaust gas is ejected out of the rocket nozzle at high speed. So later if you cannot follow the sentence I gave, you can just watch the video later, okay? Okay, and then the third one is the high speed gas produce momentum. The high speed gas produce momentum. Okay, the high speed gas produce momentum. Okay, and then the last one is according to principle conservation of momentum. Okay, so the rocket, okay, the rocket acquires a large momentum forward. Okay, the rocket acquires a large momentum forward. So I explain. So you know that the oil will enter the combustion chamber here. So there will be oxygen in the combustion chamber. So there will be a burning process, okay, occur here. So after that there will be a gas, okay, a very high velocity of gas, okay, come out from the nozzle here. So since you know that the gas is moving in this direction to the right, okay, so the hot gas will move in this direction. So you know, based on the principle conservation of momentum, there will be a forward, okay, forward force, okay, going in this way. Okay, so this is according to the principle conservation of momentum, right? So the next one is you have to improve the design of the jet engine so that it can be used on larger jet airplane that travels at high speed. Okay, so it already give you the actually what you should modify here. So have a 1, 2, 3, 4, 5. So means you have to modify these 5 characteristics. Okay. So the first one is the number of blades. Okay. So the number of blades must be higher. Okay. So the number of blades must be higher to increase the air intake. Okay, to increase the air intake. Okay, the number of blades should be higher to increase the air intake. So there's more air here means more oxygen. So with more oxygen means more fuel will be burned. Okay, so you can produce more high velocity of gas here. Okay, and then the second one is using the strong material. Okay, strong material. Okay, so long lasting. Okay, long lasting. Okay, and then the number of fuel injector also must be high. So high number of fuel injector. So more fuel will to be burned. Okay, more fuel to be burned. Okay, and then another one is the size of the combustion chamber. So the size of combustion chamber should be big. Okay, so bigger. So you can use the same reason. Okay, more fuel can be burned. Okay, more fuel can be burned. Okay, and then the next one is the size of the nozzle here. So the size of the nozzle should be smaller. Okay, so because you know where if it's smaller, so the velocity of the gas, okay, the high velocity of the gas will be increased. So if the velocity of the gas is increased, means the momentum here is increased. So of course, the rocket will have the opposite, okay, will move in the opposite way in the higher velocity also. Okay, so the last one is decrease the size of nozzle to increase the velocity of ejected gas. So this one is to increase the momentum. So when the momentum going to the left, going to the right increase, of course the force, okay, produced to move the jet to the left also will be increased. Alright, the next one
Teacher,
is, yes,
can you repeat number 3?
number 3. This one. Which one? Oh,
Yeah,
the
yeah,
number 3.
yeah,
I mean,
yeah,
then now increase the number of fuel injector, isn't it?
yeah, yeah.
Okay. So to increase the number of fuel injector is, the reason is more fuel to be burned. More fuel to be burned.
Okay,
More.
thank you, teacher.
Okay. Alright. We go to the next one. So this one is also essay questions. Okay. So the diagram 9 shows a stationary motor on a ground surface. Okay, so diagram 9.2 shows the motor and the bullet after the motor has been launched by remote control. So this one is actually like a pistol before. Okay. So the next question again, what is the meaning by momentum? Mass multiplied by velocity. Okay, and diagram 9.1, using diagram 9.1 and diagram 9.2, okay, it asks you to compare the momentum before and after the bullet is launched. So means this one according to principle conservation of momentum, right? So the total momentum before and after the bullet is launched must be same. Okay, and then using the diagram 9.2, okay, so using diagram 9.2, so this one you have to compare the magnitude and direction of the momentum, bullet and motor. So this one seem like the pistol, right? The magnitude is same, okay, but the direction is opposite direction, okay. The direction of the bullets and the mortar is in opposite direction, but the value or the magnitude of the momentum is same. Okay, and then the next one is name the physics principle. So this one is principles conservation of momentum. Okay, right, for C. So this one is actually not momentum. This one is actually the inertia. Okay, so asking you, okay, which tanker is safer to be used? So of course the diagram 9.3 or figure 9.3. Okay, so why? Okay, so the second mark is small tanks. Okay, small tanks will be, oh sorry, small tank with distributed mass. Small tank with distributed mass. Small tanks with distributed mass will have small inertia. Will have small inertia. Okay, so because if like this, only like one. Okay, but this one you divide already the mass to 5 partition here. Okay, so the small tank will distribute mass with will have small inertia. So the second one, okay, the third and fourth mark is this will reduce the inertia. This will reduce the inertia impact. Okay, this will reduce the inertia impact when the tanker stop suddenly. Stop suddenly. Okay, this will reduce the inertia impact when the tanker stops suddenly. Okay, this will reduce the inertia impact when the tanker stops suddenly. Okay. The next one is, okay, so this one you are required to give some suggestion to improve the design of the lorry so it can be used as a tanker. Okay, so it can transport petroleum and safer. Okay, so the type of brakes. So this one is actually we use ABS, okay, anti-brake lock system. Okay, ABS, okay. So the reason is to prevent wheel lock, to prevent wheel lock for safer braking. Okay, ABS to prevent wheel lock for safer braking. For safer braking. Okay, I repeat, prevent wheel lock for safer braking. Okay, and then the next one is the number of tires. So high number of tires. So this one to decrease the pressure. Okay, so decrease the pressure because when the number of tire higher, so means the surface of area also will be high, right? With that touching the ground. So means when the area is bigger, the pressure will be lower. So the size of tanks, okay? So the size of tanks means you can put whether there are two answers, okay? Whether you can put a big tank, okay? So mean it can transport more petroleum, right? Can transport more petroleum. Or you can see another one is split, okay? Split, okay? Split the tank into small compartment, okay? Split the tank to small in compartment, okay? Split the tanks to small compartment. So this one is to reduce inertia, okay? Like the one that we choose before for the 9.3, right? So split the compartment into the split the tank to small compartment. So this one to reduce inertia, or you can say big, so more petroleum can be transported. Okay, the material for making the tanks so should be strong, okay? So long lasting. Okay, or you can say does not react with the oil. Okay. So otherwise also but usually we just use strong lah. It's easier. Okay, strong, long lasting. Okay, the distance between the trailer and the tractor. So you must have a distance. Okay, so the distance must be big, okay, or must be further, alright. So this one is to ensure the trailer will not collide with tractor. Okay, ensure the trailer will not collide with tractor. Ensure the trailer will not collide with tractor. Okay, so let's say there be an accident like that. So there's like a safety lah. Okay, so the tank will not collide with the uh will not collide with the tractor there. So if not, because this one you transport petroleum, right? So if the trailer collide with the tractor, so there will be explosion there. So there must be a distance, okay? So to ensure the trailer will not collide with tractor. Okay, for number two, actually this one we already discussed in the online class before, okay? So what does it mean by momentum? Okay, you can see they always repeat the same question, right? So mass multiplied by velocity. So what is the function of the fins on the bottle that want to increase the stability? Okay, so this one, asking you to find the velocity. So it already give you the momentum is 0.8. Okay, so momentum is 0.8. So P is equals to mv. Okay, so P is 0.8, right? And then the mass, okay, the mass given is 0.4. Okay, so you have to find the velocity. So 0.8, okay, 0.8 divided by 0.4, you got 2 ms negative 1. Okay, and then D, give one suggestion how to increase the velocity of the rocket. So the first one you can put reduce the mass of the rocket material. So reduce the mass of the rocket material. So this one we usually use a plastic bottle because the mass is lighter. Okay. So reduce the mass of the rocket material. Okay, so far are you okay?
Okay, teacher.
Alright. Alright, the next one is not this one. Okay, so the last one, page 72. Alright, this one is paper 2. Paper 2. Okay, this one is essay section C. Okay. So you see diagram A shows a boy of mass 60 kg standing in stationary boat of mass of 50 kg. So diagram B shows the boat move away from the jetty with a velocity of 6 ms negative 1 when the boy jumped to the jetty with a velocity of 5. Okay. So again, what is the meaning of momentum? Mass multiplied by velocity. Okay, and then it said, what is the total momentum of the boy and the boat in diagram A? So you can see here because it's not moving, right? So it already state here stationary. So means not moving. So the momentum is 0. So the total momentum is 0. Okay, and then it say here, alright, calculate the total momentum of the boy and the boat after the boy jumps to the jetty. Okay, so this one, okay, you have to calculate. Okay, so you have to calculate this one. So using the formula, we calculate first the momentum of the boy first, okay, and then we calculate the momentum of the boat. Okay, we calculate one by one. Okay, so the first one is for the boy, the momentum for the boy. So P is equals to mv. So the mass of the boy is 60 kg, right? The velocity of the boy, you can see because it moved in the right, to the right. So usually to the right, you can see because there is opposite direction here, right? So mean one of it you should put negative signs. Okay, but usually the velocity that moves to the left, we put it as a negative. This one we put as a positive. So you have to remember for momentum, if there's a opposite velocity, so one of it you have to put negative sign. Okay, but this one we assume that the negative is moved to the left, right? The positive move to the right. Okay, so that this is the boy moved at 5 ms negative 1, so multiply by 5. So you got here 300. Okay, but for the boat, okay, so the mass of the boat is 50. Okay, but the velocity is negative 6, so you got negative 300. Okay, so if you calculate the momentum, okay, if you calculate the momentum, the total momentum, because it asks you to calculate the total momentum, so mean you have to add these two momentum. So you got how much? You got 0. Okay, so the answer is 0. Okay, and then ask you to compare, okay, the total momentum before and after. Okay, we already know that from the diagram 11a, the total momentum is 0, right? So then we calculate the after the boy jump, okay, the total momentum is also 0. So means the total momentum is same, okay, before and after the combustion, okay. Before and after the quotient is same. Alright, so name the physics principle. So this one is principle of conservation of momentum. Okay, the next one is diagram below shows a rocket. Okay, so this one you have to modify the rocket. Okay, so it can move with the higher acceleration. Okay, but this one is already give you the characteristic that you need to modify. Okay, so it should be not a problem, but later you have to remember in SPM, okay, they will not give you these 5 characteristics, so you have to think on your own. Okay, the first one is the shape of the rocket. So the one is aerodynamic. Okay, why? So this one to reduce air friction. Okay, the shape of the rocket is aerodynamic to reduce air friction. And it's same also if the question asks you, sorry, the shape of the aeroplane. Okay, the shape of aeroplane is aerodynamic. But the shape of wing of aeroplane, that one is aerofoil. So you have to remember it's different between the shape, the body for the body of aeroplane and also the shape of the wing of aeroplane. Wing is aerofoil, but the shape of body of aeroplane must be in aerodynamic. Alright, and then the next one is the material used to build the rocket. So this one again is strong, okay, because long lasting. Okay, and then third one is the additional supply needed that enable the rocket to move in outer space. Okay, this one is oxygen because you know you have to move. Okay, at the outer space means no oxygen, so you have to put the oxygen. Okay, why? So the astronaut can breathe in aerospace. Okay, in outer space, oxygen. So the astronaut can breathe in outer space. Okay. The next one is structure of the rocket. So the structure of the rocket, you know, like when the they say if the rocket start to move, right? So when it goes up, okay, it will release, okay, it will release one by one the fuel tank. Okay, so after it finish after it finishes the fuel tank, it will release. Okay, drop down. Okay, drop the fuel tank. So means after that, then the mass will be reduced. So when the mass reduced, means it can move with higher acceleration. So that was the structure of the rocket. So have several stages. So the answer is have several stages that can be stripped off. Okay, have several stages that can be stripped off. Okay, have several stages that can be stripped off. Okay, so let's say this one is a combustion chamber, right? So behind here, okay, they put the tank, okay, the fuel tank. So when it's finished using it, it will release it, drop it. Okay, drop it. So when it drop it, then the mass will be reduced. Then it can move with the higher acceleration. Okay, so they have several stages that can be stripped off. So this one is to reduce mass. Okay, reduce mass. Okay, the last one is it said here size of combustion chamber. So you know this one must be big. Okay, so more fuel to be burned. More fuel to be burned. Okay, more fuel to be burned. Okay, this one again asking you again what's the meaning of momentum. So again, mass multiplied by velocity. B. Okay, it says here tick right for the correct answer in the box given. So you have to know whether this one is elastic, inelastic, or collision. Okay, so this one you can see is stick together. So if stick together, this one is inelastic. Okay, so like this one before, like the boat and the boy, so this one is elastic. Okay, because they are not moving together. Okay, they split after the collision, right? So this one is inelastic. Okay, so you tick inelastic. Okay, so compare the momentum of trolley A and trolley B before the collision. Okay, so it say here already, okay, trolley B is stationary before the collision. Trolley A move. Okay, so trolley B is stationary, means the velocity of B is 0. So when the velocity is 0, you know the formula is P is equals to mv, right? So when the velocity is 0, the momentum also 0. Okay, so means here, okay, the trolley A has a higher momentum. Okay, because B not moving, V is 0, the momentum is 0 for B. Okay, and then compare the kinetic energy of trolley A and B before the collision. So you know the formula of kinetic energy is half mv square, and trolley B is not moving. So mean the V is 0. So the kinetic energy for B is also 0. Okay. So the answer here, the kinetic of trolley A, the kinetic energy of trolley A is higher. Okay, and then compare the total momentum of the trolley before and after the collision. So this one must be, the answer must be same because we have to follow the principle conservation of momentum. Okay, and then the next one is compare the total kinetic energy of trolley before and after the collision. Okay, so we already done the question about the velocity of this one, the essay one, that you have to add the total momentum. Which one? Wait. Yeah, this one. So this one you can see the total kinetic energy, okay, before the collision is higher, right? So the question is, okay, so they said compare the total kinetic of trolley before and after the collision. So the total kinetic energy before the collision is higher, right? So for D1, it said based on the answer in 5C3. So state a conclusion about the total momentum. So again, the total momentum before and after the collision must be same, right? And then number 2, it said name the physics principle involved in 5D1. So this one is principle of conservation of momentum. Okay. So we finish about momentum. Okay. So the next part, okay, we go to the this one. Okay. Impulse and impulsive force. Okay, so what you should know about impulse and impulsive force. Okay, so impulse, the meaning of impulse is change of momentum. Okay, and then the ft is equals to mv minus mvu. So this one you can use both or you can use either one. Okay, so which formula you need to use, you have to see the question, what the information given. So let's say they give you force and time, so you use this one. They say it gives you the initial and the final velocity and also mass, you use this one. Okay, so it depends on the question, or sometimes you can use both also. Okay, see which one, which info the question give you. Right, for the impulsive force is rate of change of momentum. Okay, so this one is the formula for impulsive force. Okay, so when the time is decreased or time of impact is decreased, the force, impulsive force should be increased. If the time of impact is increasing, the force, impulsive force will be decreased. So this one is the inversely proportional relationship, right? So I give you time, right? Okay, this one. Oh wait, I see whether you can move to the next part of the equation. So after this is forces and equilibrium, I think. Wait. No, this one is gravity. Is it mainly? No. Okay, so I do 2.6 and 2.7. Okay, so 2.7 is the gravity. Okay, so when the object is said to be free fall, okay, so that means the object falls only due to the gravitational force only. Okay, usually they give you a question, let's say there is a coconut, right? Coconut okay, fall down, okay, and then it asks you what is the constant value for the coconut. So because you know the coconut falls due to the gravitational force, right? So means the gravitational acceleration must be same. That is the constant value. Okay, and then weight is a gravitational force that acting on the object. This is the meaning of weight. Okay, cannot use that mass multiplied by gravitational acceleration. No, cannot use that as the meaning of the weight. Okay, so weight is actually the gravitational object that acting on the object. So the formula is W is equals to mg. Okay, m is kg, g is the acceleration. Okay, and then the forces acting on the object. Okay, so let's see for the lift, right? So lift, I draw. So that is the three condition for lift. Okay, so the first one, so let's say this is the lift. Okay, there's the people here. Okay, I draw three. Mm, okay, so the first one, the lift is not moving, stationary. Okay, so this one is stationary. Okay, stationary. This one, the lift will go up, and then this one, the lift will go down. Okay, so if stationary, there are two force. Okay, there are two force acting. Okay, on this person. Okay, the first one is the weight. So if you want to label the weight, okay, it must be from the center of the object. So I label here as W. Okay, it must be from the center of the object. So let's say this is the object, so must be on the center. Okay, if you write it like this, W, so this one is wrong. So must be at the center of the object. So this is weight. Okay, and then there's another force, okay, acting on it. So we call it as the normal force. Okay, normal force, or this one is R. Okay, this one is R. So normal force, this one is R. Right. So because it's stationary, so means it's not moving. So mean if not moving, it's in the state of equilibrium. So R is equals to W. Okay. And then for this one, okay, again must be a weight here. Okay, and then must have the normal force R here. Okay, so this one the lift goes up, right? So mean there is force acting going up, go up like this. Okay, so how you want to find, let's say the question asks you how to find the reading of the weight balance. Let's say they put a weight here. Okay, so you want to measure what is the weight. Okay, so this one the weight is actually equals to the, okay, R here. Let's say the weight is, the mass here is 50 kg. So if you want to change the weight, so 50 times 10, right? So it's become 500. So means the weight is 500, and also the reading of the weight balance here is also 500. Okay, so let's say you can see here R and F. Okay, this one move down, this one goes up. So you can see there are two force here. Okay, acting going up, right? There are two force here is going up. So means here is bigger than, yeah, up is up is bigger than the below direction here. Okay, so mean this one we have, if you want to find, okay, so R minus W is equals to F. Okay, because R is bigger. Why R is bigger? Because the F force is going to the R direction. Okay, so and then if you want to find the reading of the weight balance here, so the R is actually F plus W. Right? Okay, and then this one again, this one is R, and then this one is the weight is W. So this is the force. So with this one, which one is bigger? The weight, right? Because the force is moving, okay, in the same direction as the weight. So W, okay, minus R is equal to F. Okay, W minus R is equal to F. So you want to find the R, right? So this one I change to this to here, so it will become positive, and this one I change to here, so negative. So this is how you want to find the reading of the weight balance here, weight scale, weighting scale here. Okay. So this is, you have to remember, you have to follow direction. If the force goes to the R direction, means R minus W. If F goes to the W direction, so means W minus R, we have to arrange back the equation so you can get the reading of the weight. Okay. So that is for the lead, right? So since we still have time, like 30 minutes, so let's try the question first for the impulse and impulsive force. Okay, try the objective part. For this one. Okay. Hmm.
Teacher is answer for number 9D.
D, donkey.
Yeah, yeah.
The answer is B, boy. You use what as a, this one you use what formula?
MV minus MU. MU.
This one is impulsive force, right? Impulsive force is F is equals to mv minus mu divided by T. You use this formula?
Oh, I forgot to divide by T. Sorry.
That one is actually impulse. The one that you calculate, I think that one is impulse, not impulsive force. So others, you get the answer is B.
Yes, I got B.
Mm. So this one is 55. I show you the calculation. Okay, in case you don't know. Okay, so you will assume as 0. Okay, we assume that before that the board is not moving. Okay, sorry, just T, this T is 2. Okay, so I got 330 Newton. Right. The next one is, right, the unit of for impulse is same with unit for The same unit with what? Okay. So the answer is okay. So impulse is this formula, right? So M is mass, so kg. Okay, V is velocity, so ms negative 1. Okay, so this one because the unit is same, right? kg, ms negative 1, 2. So they share the same unit. So this is the unit for the impulse. So the answer, okay, so the answer is mv, right? So mv is a,
Momentum.
yeah, good. So the answer is D. Okay, for number 7. So this one is to calculate the impulse. So impulse is Ft equals to mv minus mu. So you have to see what the information give to you. So you say diagram C shows Ahmad bends his knee when landing in a long jump competition. He lands on the sand with velocity 5. So the mass of Ahmad is 60 kg. So this one you have to use mv minus mu. Okay, we cannot use ft because there's no time given here, right? So we use the mv minus mu. mv minus mu. So the mass of Ahmad is 60. Okay, so the mass of Ahmad is 60. The final velocity is 5.
5.
So you got 300, correct?
Yes.
Okay, this one is easy. Okay, the next one. So diagram 5 shows a high jumper landing onto a mattress. So which graph shows the correct relationship between the impulsive force and the time of impact P acting on the jumper upon landing? So you know that I already told you that the relationship is inversely proportional. Okay, but this one you have to see the axis here. So this one, the axis is 1 over t. So 1 over t should be, the answer is d donkey. Okay, d donkey. Okay, number 8. Okay, the airbag is designed to, okay, you can find to answer here whether reduce impulsive force or you can say lengthen the collision time. So the answer should be C. Okay, whether you find the decrease impulsive force or lengthen the collision time. We have to see the situation. So this one, of course, the airbag is used to decrease the impulsive force. Okay, and then for number 9, okay, so this one is impulse. So impulse is whether we use Ft or we use Mv minus Mu. So this one they didn't give you, they only give you the S, okay, the distance and then also the mass. So how you want to find the impulse here? So this one you have to use the equation of motion. Okay, we have to use the equation of motion. There is S is equals to ut. Okay, I wrote it here. Okay, because when it jumps, so it will fall under the gravitational acceleration, right? So S is equals to ut plus half at squared, right? Okay, and then the S here is 2 meter. Sorry, 2 meter. Okay, so we assume before it jumps, the initial velocity is 0. Okay, And then his jumps due the acceleration must be 10, right? Because it due to the gravitational acceleration. So t square, right? Then find the t. So what's the t here? Zero. You got 0.63. See?
Teacher have to get 0.63.
Okay. Alright, so this one we can cut it down. It become 5, right? So 5t square, right? And then this one, 2 divided by 5 is t square. So 2 over 5 is 0.4. So t square, so t is square root of 0.4. Did you got the answer? Okay.
Teacher,
Okay.
so the T is 0.6.
T is 0.63, right?
Yeah.
You have to take like, if there's a lot of decimal point there, you have to take until 2 decimal point.
Alright, teacher.
Okay, and then the next one is still not finished because you want to find the impulse, right? So Ft is equals to mv minus mu. Okay, so you already got time here, right? And then where you want to find the force, okay, you use the mass, okay? We use the mass, okay, and we change it to Newton. So 50 times 10 here, okay, I change to Newton, okay, and then the time we already calculate 0.63. So you got like 315 Newton second. Is it okay? We cannot use this one because they don't have give you initial velocity, final velocity. Or if you want, I think also can. You can find the V, but you use this formula. V square is U square plus 2as. Okay, same, right? But I use this formula. It's depend on you. You still can get the same answer, right? So the answer should be 315, 316, that the nearest one, because we have a lot of decimal there, right? Okay, so the answer is B, boy. Alright, for number 6, this one you have to combine the one that you learned, the tape, right? How to find the velocity, okay, and then the time there, okay. So let's calculate together. Okay, you try to on your own first recall that what you have learned in 2.1, I think. No. Okay. Mm. 7.6. Yeah. Sorry. What's your answer? You got the answer?
Teacher, no, I didn't get.
Okay.
Teacher, I also didn't get.
Alright. So we start first. So this one is F is equals to MV minus MU divided by. So sorry. Okay. Divide by here. Okay. So the mass should be no problem because the equation already give, right? So the problem is V and U and also T. Okay, so if you see the question here, so this is before collision and this one is after collision. Okay, so the after collision, okay, the after collision is V, right? The before collision is U. So how you want to find U and V? Okay, so you learn in the 2.1, right? The ticker tape part, right? So if you want to find the velocity, okay, you have to know the length, okay, the length and also the total time. Okay, so the length here is 7.6. Okay, but you can see here they use the unit Newton, right? So when they use the unit Newton, means you have to change the cm to meter. So 7.6, okay, divide by 100, okay, 7.6 divided by 100. So you got 0.076, okay, 0.076. So here I change 0.076. Okay, I change to meter. Okay, and then another one, you have to find the total time because velocity is displacement divided by time, correct? So the time here you have to, okay, you have to calculate the total time. So I make it bigger for easy for you to see. So the time here you found the tick. How many ticks are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 ticks there. So you know that one tick is equals to 0.02. Okay, so 10 multiplied by 0.02. Okay, so and then after that you calculate. Okay, so you calculate, you got like 0.38, isn't it? Okay, right. So try to calculate V. I give you time, so try to calculate V. Then try to calculate V. This one you don't have to calculate the tick because usually they will divide if the ticks is equal, okay, equally. Okay, so the number of ticks should be the same. So you don't need to find the how many ticks that just divide. Okay, and then tell me your V. Okay, so V, don't forget to change to meter first. Okay, 0.04, I think. Okay, and the total time is 10 multiplied by 0.02. Okay, so you got 0.2. Okay, if you have a problem, then you stop. Okay, you sit using your mind. Okay, the next one is the time. Okay, so V already settled, U already settled, mass already given. So now its problem is the time. So the time here you should find because the time of impact means the change. Okay, the change of momentum before and after the collision. So what is the time taken for the change of momentum then? So the change of momentum is here. Okay, so you need to find the time here. So 1, 2, 3, 4. Okay, so the time here is 4. Okay, 4 multiplied by 0.02. Okay, sorry. So you got 0.08. Okay, now you have already got mass, velocity, use already, you've got full info already. So you can use calculator now and calculate. So then give me your answer. Okay, just substitute in that formula. So
Teacher,
what?
is it C?
Yeah, the answer is C, 2.25. Okay, is it okay?
Okay, teacher.
Alright, good. Okay. So diagram shows an airbag function when the emergency brake is applied by the driver. So this one is actually to reduce the, okay, which one is? There is no impulsive force here. Okay, so what's the answer?
Uh,
Uh,
in a
Indonesia.
Uh,
Indonesia is seatbelt.
D.
The
Donkey.
answer, yeah, the answer is D. Rate of change of momentum. Okay. Right, for number 10. Sorry if my house is quite noisy then now. MV minus Did you get the answer?
calculating.
Okay. Number 10 and number 111. I don't think there's no answer.
Teacher, I cannot find for number 10.
Yeah, I also cannot find for number 10.
Number 10, alright. Number 111 you can find. Or you didn't try it.
I haven't
I
do it, teacher.
haven't, because still thinking of number 10.
Okay. So let's say a truck with a mass with 250 kg is moving by velocity 20 before collides with a tree and stop in 0.05. Okay, so what is the magnitude of impulsive force acted on the truck? Okay, so it moving before it collides. So this one is actually U. Okay, so let's see. Sorry. F is equals to mv minus mu divided by T. So the mass is 250. Okay. And then before it collides, so means you want this how is the amount? Okay, this the velocity is 20, right? So the 20 is U. Okay. Moving before it collides with a tree and stop in 0.05. Okay, the U is 0 here, sorry. Right? So the U is 0 here, so this one is 20. So minus this one 0. Okay, and then the time is 0.05, right?
Yes.
So you got the answer is 1 times 10 power of 5. No answer.
Yeah, teacher, I got this and there's no answer.
Yeah, that's why I said no answer. Okay, and then the next question is, okay, an object of mass 1 kg is thrown towards a wall with a velocity of 5. Okay, so the object then hits a wall and stops in 0.2 seconds. So if the impulse force exerted on the object during collision is 25. So this one you have to use the same formula. Okay, alright, so the mass here is 1. Okay, but the question already give you the force, impulsive force, right? So I just replace F with 25. Okay, and then the mass is 1. Okay, and then the velocity is you want to find. Okay, and then minus, okay, 1 multiplied by 5. Okay, and then divide by 0.2. Okay, so try to calculate what's the answer here. I got 10. Did you got 10?
Teacher, I get 1.
1?
Hmm.
What is that one?
I got 10.
Oh,
Wait.
sorry, I
Uh-huh.
think I thought I got 1 as well. I accidentally typed wrongly in the calculator.
So this one is 5, isn't it?
Yeah.
So V minus 5, right? Then V is minus 5 goes here, become 5 plus 5. So it becomes 10.
10. Yeah. I typed
Okay.
wrongly in the calculator.
So the answer is 10 ms negative 1.
And there's no answer.
Yes, again, no answer. Okay, so this is the last question before we stop. Okay. Alright. For the paper 2. Okay. So what is the meaning by free fall? Okay. So actually, what is the meaning of free fall? Is the that object falls due to the gravitational acceleration only. Okay. Object falls due to the gravitational acceleration only. Okay. So the number for B, so it at least takes 2 seconds to fall from A to O, right? So asking you what is the acceleration. Okay, from M to O. So the acceleration of the athlete at stage N. So this one you have to use what formula? Try to answer first. Oh. Okay, we start until B. So let's say we continue. I give you the answer for impulsive force and also for the gravitational, for the gravity. So two topics tomorrow. Next week we discuss the answer. Okay. Then
Sure.
we go to the next. Next one is. Oh, this one is chapter 2, part 3. You already got the answer for B1, B2, and B3? Not yet. Okay, did you got the answer? Okay, let's see for question number B1. Okay, B1, what is the acceleration of the athlete at stage N? So if you read the question here, it said that the athlete undergoes the free fall starting from M. So we already know that free fall means it fall under the gravitational acceleration, right? So of course the acceleration here is 10 ms negative 2. Okay. And then the next one, calculate the velocity of the athlete just before he drops on the mattress. So you know the acceleration is 10. So we can use this formula. So the acceleration is 10. Okay. So V you want to find. So let's say the U is 0. Okay. And then the time is already, okay, sorry. U is 0. Okay, and then the time is 2 seconds, I think. Okay, so you got the V is 20. Okay, 20 ms negative 1. Okay, and then the next one is, or you can try to use this formula also. Okay. So wait, it gives you S? No, right, wait. It gives you S? No. Or it didn't give you height. So we cannot use V equals to U square plus 2AS. Because the question does not give you S here. Okay? So only you can use this one. Okay, the next one asking you to find the kinetic energy. So the kinetic energy is half, right, mv square. Okay, so the mass, okay, the mass is 65. Okay, so 65. The velocity already count, like 20. So the kinetic energy should be 12,400 joule. Okay, so this is the answer for the B3 part. Okay, is it okay? Before I stop until here.
Yes, teacher.
Yes, teacher.
Okay. So I see you tomorrow, right? 1:30.
Yes.
Yeah.
Okay. So good night.
Good night, teacher.
Right. See you.